will be your file.
Yeah.
Thank you.
Okay, so since it's recording, since it's almost very difficult to go through every feature in Topspin, so the manual is really where I start to learn. So if you want to know how to do certain 1D experiments, 2D experiments, all of them are here, which then really goes through from obviously the intricate basics of how things work. But what I like about it, so the basic is really nice because it really goes through how it optimizes a sample, from tuning it all the way down to shimming it, if you want to understand what it means by getting a good line shape. And then it goes through the very basic experiments, tells you what the pulse program is, how to create your data set, and to run it. And it goes all the way down to 2D experiments, so all the ones that I put in there from COSY. So you have some Toxy experiments, which is basically long-range coupling. You have your depth experiments. All tells you when you run it, why run it, what does it do. So you just have to go through this, clicking on the icon, and get your result. Really nice, easy way to do it.
It's not on the same menu you showed us in the morning, right? This menu.
Well, this is in Topspin. So what I showed you was all in Assure,
Yeah.
but Topspin is obviously the main software where you're going to run your experiments and everything. And if you click on Help, the manuals are all there. So if anything you really want to know, I mean, if you really want some fancy experiments, the 2D, even fancier, you can do some 3D, which will take forever, and then all the way down. So
You have there like how to do the quantification and all?
quantification is also in here as well. That's quantitative NMR.
Okay.
So even if you're like, oh, I don't know how to process certain something, processing, acquisition, it goes through a whole manual if you want to know how to do it in depth. However, for the quantification, I'm going to try to teach you in this software, so it's easier to do it. On Topspin, you couldn't do it, but I find it a lot more difficult. I shouldn't have recorded that, but whatever. People are like, what? So let's make a method and run the method, and we can try to quantify something. So let's see. Why don't someone do it? And then I will lead the way. So at least someone like clicks on it. I feel like I'm the only one clicking on it. Yeah, you want to, and then we'll take turns. Like you guys do a certain part, and then someone else takes over, and then we'll go from there. Okay. Okay, we'll switch seats.
Guiding.
So everyone, by the end of today, will play on this instrument. And there's really no way to break it. No way. Okay, so we're gonna make, since you guys don't have any compound set up yet, we're gonna make an arginine method from scratch. So first thing you need to do is to start quantify. So click on quantify. So we're gonna start a new method. So whatever you do,
Here.
so the top tabs, go to quantify. Is that quantify or
Quantify.
Okay, and then you're going to start a new method. So we're doing a targeted method. And then we want to select an S space. So the botanical obviously is not the one we want to use. So let's click on that.
This one?
Yes. And RMSS base 1. Yep.
Okay.
Contains it. And because we're going to make an arginine method, and why not make lysine the adulterant or something like that, we're going to need to pull in those compounds, obviously. So let's pull in those compounds.
This one?
Yeah. So you can click your other hand, click on Control, press Control, so you can click multiple samples. So
Okay.
you can have arginine, and right below it there was lysine. So if you go back up, lysine, perfect. And what else is in there? There's DSS. So let's see if there's DSS. Oh, there's water, so we can click on water. There's DSS and
TSS.
no, there's no DMSO. Oh, if we go down a bit more, oh, okay. You know what? We'll add the DSS on its own. So now, if you look at the proton is selected, but we're not going to have it in 1D NO DMSO 300. So if you click on that,
This one?
this basically shows you all the names of the experiments for each of those compounds.
Okay.
So this was run in D2O, so we just scroll down. 1DNO, D2O, and this was 400, so we'll go 400. And then you're going to click continue using those compounds. So now it's basically going to that space being, okay, give me arginine, give me lysine, and then give me the water.
Go to
So here the
space.
compounds we choose is
Just
the
click from
solvents
quantify.
and the
You
main
go to
compounds,
space and
right?
new
Mhm.
method. Then
But the,
So
how we
recording.
don't know what's the main compound.
Well, for this method, we know what the main component is. I mean, if you don't know
Yeah,
what it is, then more likely you will run it without a method in the beginning.
just the methanol.
Yeah.
No, just the solvents. Right?
You could, yeah, you can run just the solvents, for sure. So let's see.
you said we don't know the method.
We don't know what's the main
Main
compound.
Yeah, if you
from our
run
sample.
something completely fresh, then
no,
I
no,
mean,
just the solvents.
Okay.
it's hard to pull in any compounds. In.
Okay.
So let's see. So you have all that ready to go. You don't have DSS in there. It's supposed to be in there. Let's click on interactive edit. And it goes load a 1D spectrum, because obviously it can't just paste it on an empty screen. So we need a spectrum there first. So let's try to load the spectrum that we ran just a while ago. So we click browse, yeah. It was in C, so go to my computer, C, Brooker, Thompson 3.2, data, NMR2, and then let's go sample test. You know, just click back one, yeah, and just click open for a sec.
This
Open,
one?
yeah. So basically here it's going to read through. So what you can do here is, for the data set name, for a sample, delete that. Yeah, and then put about a star. So what this is like a wildcard. Can you just load everything that's in that sort of folder? Because I really don't know what's in it. An experiment number. Let's
Here?
put the experiment number below it. The second. We're going to put a wildcard as well.
What do we have to put?
Star. Sorry.
Okay.
Processing number could be 1, because we know it's a 1D. I don't know if that's going to give an error. So click OK and see what happens. Okay. So it's going in that folder and loading all the spectra that they can find that's a 1D. So let's expand that a bit. Just open that window up a bit. I believe the sample was test sample. So not this one. We've got to go down. It's test. So it's going to be T. Yes, where is it?
I don't see anything like
Sorry. Let's see.
STT or T.
Let's find that sample again. Oh, it's not this one. Okay. Where was the sample we just ran just a while ago? Let me see. February 10th. Oh,
Oh.
okay.
It's in a different tool.
Totally did not name that. So February, this one here,
Mhm.
10-1. So
Mhm.
this was your sample. So you can push that in, just click OK. So it pulls in the compound and obviously overlays the areas that you want. So let's just expand just the area that you want to focus on. Awesome. So from this method, you can instantly see that there's one area we really didn't define, and that is at 0, right? So what you can do then is right-click, go define new compound and region interactively. So here, just kind of put in where you want it, like drag a region, somewhere like that, let's say. Yeah. And click stop. So here it's going to say, okay, you defined a new region. Did you want to connect that with one of the compounds you made, or did you want to create a new compound? So here it's going to be a new compound.
New compound.
Yeah. So you can just tick that tick, click OK. So it's going to be like, okay, what is it? What's the compound name?
Mhm.
So we're going to put DSS.
Okay.
Average mass. This stuff you could look on Wiki for that. NMR, the type. We open that.
This one.
Yeah.
Okay.
And then you're going to go to NMR reference.
Reference.
Okay.
Okay.
And then right below you see spectrum match. We're going to turn that off because
This
our
one.
S-Space didn't have it. So you can see here in this window as well. I'm not sure if you guys will ever use this area, but there's apply min concentration, apply max concentration.
Mhm.
So what this means is really for quality control, like if you know this compound should not be there, so if it passes a minimum concentration, then it will fail. There's a max concentration, like if you know that there's this sort of vitamin that's supposed to be there, and they say that it's going to be 10%, but it's 5%, it will fail because it should have been higher than this amount. So this is just
Okay.
more certain criteria. I don't think you guys would use it, but just to explain it. So click OK. So this window here is basically for this region. If you see the count there, this is the number of protons that are there, right? So
Count this number of protons.
yeah.
Mhm.
So for DSS, you can, that's 9 protons in that area. And from and to, that's just obviously your region that you selected. The line shape is usually a singlet. So instead we're just going to click on that. We're going to put in region. So here you can select the different shapes. And then you can click region to set, I just want to quantify that whole area. So we're going to click that. Multiply constants, intensity, all that stuff, really, you're not going to need anything for this area. But this is really when you want to get into intricate detail fine-tuning. So what this means is, let's just say that there is a doublet that's in that region, and doublet, technically the intensity of the two peaks are exactly the same. So it should be exactly the same. So the intensity tolerance is if it's a bit off in one side or the other, do you pass it or not? Because when you analyze complex mixtures, something that's equivalent like this, fine. But if it's like this, how do you know that is one compound? Because technically, if it's the same here, there's this leftover residual that could be another compound there. So usually give a tolerance in what you think that it should be. That is fine, since it's just a singlet. And then all these other stuff here, I don't think you would need to use as much, the fine-tuning for now. So we're just not going to focus on it. And then just click OK.
Okay.
Now, if you can see from the spectrum, everything is red. So it's saying that you're going to quantify every single thing there. You really don't need to. I usually try to focus on quantifying areas that
Necessary.
aren't even necessary, really. Like areas that it's just a mess of peaks, I usually don't want to quantify in that area. So what we can do now is right click, edit method. So first DSS is considered NMR reference. Let's go to water. So you see the compound water. It's beneath compound name.
This third.
This one?
This
Oh,
Yeah, and then we're gonna double click that. And it's not a main component, so we can put type. So on the type below it,
oh, okay.
yeah, we're gonna select it as a solvent. So what this means now, if it's a solvent, it's not considered a main component. So if it's there or it's not there, it's not gonna fail it. It's just spectrum range. Sure, okay. And then so for the 1H tab on top, we can turn quantification off. I really don't need to quantify water in this one. You could have it, but yeah, you can turn that off. So then you click OK. So everything that you turn off,
Mm-hmm.
if you go back to interactive edit now, it changes color. So for solvents and NMR references, if you're not quantifying, it turns to black. Okay, so let's find areas in which we want to quantify. So if we go on the 3.8 area there, if we just kind of zoom in a bit more, yeah. So this area is a very difficult area to quantify because arginine and lysine are almost exactly in the same region.
Mm-hmm.
So we're not going to quantify those. So we're going to turn those off. So basically for each of the individual regions, we're just going to go near it, hover around it. So go down, move the mouse down, and then right click, edit region, and then on top to quantify, we're going to turn them off. So off, okay. And then the other region below it, I'm going to turn that off.
This one?
Yeah. So you see it's very much interactive where you use telling it what it should do. Okay, so let's zoom out. So what you can do is if you go up, you see the green thing there?
Mm-hmm.
If you kind of move the mouse, you could go to an area where you can drag it. So move the mouse a bit. Yeah, so you can drag it, and not only that, move around the mouse. So if you go here, you can take it and you can also make it bigger.
Mm-hmm.
So make it bigger again.
By dragging that?
Yeah, sure. And then if we look at 3.2, arginine is there with that triplet. That's a perfect region. Fine.
Mm-hmm.
Lysine, this sample didn't have lysine. It's fine. We're going to run a sample with lysine. And if we go to the region of 1.9, 1.8, if we just kind of make the intensity bigger by using your middle mouse a bit.
Okay. You mean, sorry.
Oh, don't worry. So you can go back up and then just reset the second last icon. Yeah.
This one?
Yeah. That just resets it. So you
Okay.
can rezoom in or wherever you want.
So it was here.
Yeah. So just awesome. And then the middle mouse button kind of just scroll up. Yeah. So that just
Intensifying.
Yeah. So those areas are really not good areas to quantify. So let's just turn them off. So
Here?
So yeah. So here you can go to individual ones and click off, off, off. If you want to make it easier, what you can do is click cancel. So right click on the same region again. Go edit compound.
Okay.
So when you edit compound now, it's going into arginine. Let's go to proton tab. So we know we wanted to quantify the peak at 3.305, but then all the other ones, we really didn't need it. So from there, you can turn them all off. So the top two,
Yeah.
they're off. Something like that.
Mm-hmm.
So, okay. And then let's do the same thing for lysine.
Here. This one?
Yes. lysine, now we look at the proton tab.
Okay.
We already want to quantify the one at 3.0
3.0
something.
first,
So all these ones we really don't need.
so that's it.
Yeah.
Okay.
So when do you need to quantify one area and when do you quantify more than one area? Technically, one area would instantly tell you the quantification already.
Mhm.
The reason why sometimes you quantify more than one area is just to see how close the number is to each other.
For my compound, I have a question. So for my compound, it comes like close, like how you showed me, like two for ursolic and olenolic acid. It comes like very close. Like you can't even differentiate between those two. Like how do you quantify those two if you have to in the mixture of compounds?
We would need to see the spectrum and see if there's a way we can resolve it somehow. So there are different fine-tuning techniques that we can do to see if we can separate those peaks and then define that region and then quantify that region. So we can, if you can show me the spectrum, then we
Okay.
can play with it. Yeah.
I have it right now, I guess.
Yeah.
So quantify you need to understand the compounds. You run the
You don't need the standard, you just need to know where the chemical shifts are and how many protons are in that area.
but
You just need to, for the quantification, you just need to run the internal reference of a known concentration of a compound, any compound, so then you can correlate that information to whatever that information is.
This is the zoomed in.
Is it still in here?
Yeah, it's in there.
Probably under her folder.
Yeah, it's data. I think get data chem student NMR.
Actually, I don't think the folder was made.
In that, like, I can like figure it out from that, but not in this.
Okay, I can just follow the one that's here. Is it the same here?
Yeah.
Okay, so let's add a new. C
Data.
data.
Nito.
Data.
A tata. Data.
Nice. I'm just gonna see if I can load up. So these are your compounds.
Mm.
Okay. So which ones?
Not this one. The combination of like the ursolic and olenolic. Ah, this one.
Okay. So do you have ursolic and olenolic?
There
So
were
this
like-
one has just ursolic, right?
This one was the better one because like when I added like 1 ml, it didn't like the phase was not like all that good. When I made it just like 500 microliters, it came out better.
Okay. So
this was a better spectrum.
this 2 makes.
Yeah.
So yeah, this is the one that's loaded right now on
Mhm,
screen.
yeah.
So this is the one.
Mm-hmm.
Okay. So the only thing, obviously, I don't know the compounds very well. Does it look the same? Did you have one by itself?
Pardon me?
That looks like a mixture.
Mixture. It's
Uh-huh.
a mixture of ursolic and olenolic, 2 different standards.
Mm-hmm. Did you run the standards by themselves? Like the top one here, this is by itself, right?
Yeah,
Okay,
just by
so
itself.
let's put that up
Yeah.
as well.
And even this is the one that is like just by itself.
Okay.
Olenolic.
So that's. bottom is the mixture, and that was a solid. Yeah, I mean, regions here for sure you can quantify. You can see here has nothing.
Mm-hmm.
Here has. So here for Osolic you can definitely quantify. Here as well you can quantify for Olenek. Right?
So near 4 and
Yeah.
3.
So only thing now is you got to know how many protons are in this region,
Mm.
right? And what's really nice is that in your S space of RMS1 or RMS2, I thought we had our solid. We didn't have it? Oh, that could be the next one. So you just need to know what's in there. That's the only.
Mm.
That's the only thing. So you need to kind of understand how many protons are in this doublet.
Mm.
And then once you can do that, you can make an assure method to just basically, can you please find this doublet and quantify? Because clearly, well, sorry, Osolic wouldn't have it there, but the olenic acid would. So then if you go back, if we keep focusing on other areas, somewhere you can see here that Osolic will have it and olenic acid would not have. You can quantify this multiplet.
Mm.
And I think some of these are carbon salides, so I think it's more just these 4 peaks. So this quartet here would you'll quantify.
Mm.
So definitely there is resolution that you could do. So this is actually not that bad. It's quite easy to do. Yeah. If you have the sample still, we can try to quantify it. We can make a method. So that's not a problem. So yeah. So you can imagine if you're going to make this method, you would put the Osolic in there, define those regions in which is not in the other one, and then when you run an icon, it will find these regions and quantify.
You mean separately?
You can make a method for both of them, really.
Okay.
Put Osolic in, and put the
Olenoic.
olenic acid in there,
Mhm.
define the regions where it's separate from each other to quantify, then run the mixture. I'm pretty sure it would just quantify those areas.
Mm-hmm.
Yeah. As well, when you pull in the compounds from the S space,
Mm-hmm.
so here I'll give it back to you. If you go in that specific region, like go to one of those tabs, yeah, and then right click, you can go show compound spectrum. So if you click on that, the blue comes up. You see the blue?
Yeah.
That is you pulled in the arginine spectrum in from the S space.
Okay.
Can you see?
So on top there, it tells you,
This one?
yeah. So this, if you right click it and close it. Now go to the lysine tab, right click and go show compound spectrum.
Oops.
It's
wait.
not sorry. Compound spectrum.
Okay.
It goes into your S space and goes, since you pulled it in there, you can tell it to come on screen as well. So this helps you as well because you're like, you know what, maybe do you need to adjust it a bit more so you can move those areas.
So how do you do that?
So for example, if you're moving now, I'm not gonna touch it. So
Huh.
you're gonna take that region there,
This one?
the tab.
Mm.
If you hold it, and you can just move it anywhere. So you can move it anywhere you
Oh.
want, basically. And if you want to make it wider, if you go to the ends of each of those tabs, so go to one of those ends, yeah, you can basically
Okay, just drag it?
Yeah. So what this means is like if you wanted a triplet in there, and you're like, oh, it shifts quite a bit, you can expand that and you now know what kind of regions to search for that triplet.
Mm.
Awesome. So then, now let's go all the way to the end of the spectrum, the DSS.
This one?
Yeah. Awesome. DSS, I guess we can quantify it. Why not? Is this going to take that entire region? We didn't have it on the spectra base, so it's not going to do any of the matching.
Okay.
So if we right click,
edit compound or region?
no, I think it's fine. It's fine by itself. Yeah. So we're just gonna just go on the screen on top here, and then right click, go edit method. Let's go report. So here we have it as a pass or fail. You have all those check for non-assigned peaks. You have all that stuff. That should be fine. Sure.
This one too?
Check for unbalanced integrals. So this is, again, just making sure that in your spectrum, if there's any areas that come out, should you check for that non-assigned peak and fail the actual report. And then check for unbalanced integrals is, again, going back to the possibility that if you had overlap, so if you had a triplet, and technically for a triplet, the two ends, the intensity should always be the same. The top's obviously going to be a bit higher. But if all of a sudden one of those ends is a bit higher than the first one, if you go check for unbalanced integral, what it means is now technically there should be that bit of information still, the residual left over. Does it still come from the same compound, or is it coming from another compound that's just lying underneath?
Okay.
For you guys, I think both of them should be turned
unchecked.
off, because this is really for QC. This is more for industry. They really want it to be, for you guys, you're going to run a lot of different things in here that's going to be quite complex. If you really go down to nitty-gritty detail, it's going to fail 100% of the time. It is, because it's just so many information in here. And so I wouldn't check those. Pass or fail as well. I really think that's more of a QC thing. You guys really don't really care about pass or fails. You just want it to be analyzed, so I put analyzed. Let's go identification. So you see it's on your RMS base D2O 400, which makes sense. The match factor 70%, you could play around with that. Max shift, so the identification, if it does shift, how far would it let it shift? So this looks like a bit different from what you did on screen, where you were kind of pulling it back and forth. How Assure does it is it first identifies it before it quantifies it. So when it identifies it, you tell it what's the max it could go, and if it fails in identification, then basically the quantification, it's not going to trust it, because I can't identify it. Then how are we quantifying this? In equation builder, we go to next tab. We're not going to do anything. Calibrate, we're not going to do anything there yet. We'll do it next one. And chemometrics, we don't have anything for this.
Okay.
So if we go interactive edit again, right click, and now we're just going to test this actual, what you did on what's on screen. So go run quantification with report. And here it can go back and forth. So it's going to tell you it failed, and you can check why it failed. Maybe you put in some sort of parameters that will make it fail or whatever, and then this allows you to do a lot of your analysis offline. So even though I said you're going to have your method all ready to go for icon, doesn't mean you always have to run an icon. So you have a really good quantification method that you made in Assure. If someone's running other experiments and you have all the other spectra already done, just pull in Assure and then just overlay your spectrum in it, pull in the method, and just quantify like what I just did now, and you can do analysis offline. You don't have to always do it in icon.
Okay.
Yeah.
Can you just show one of those, like?
Yeah, for sure, we can do
Yeah.
it for that. The only thing is, again, I don't know how many protons are there, so you're gonna have to figure that out. So we'll do one.
Okay.
Are you looking at our solid acid?
Yeah.
Yeah.
I showed
The
in the
methyl groups?
spectrum. of the combination of arsolic and the olinolic.
Oh, right.
Yeah, he was telling me like if I can make a mixture and come, then he can show.
Oh, okay.
Yeah.
Yeah. So I mean, so I should be touching. So you can. Let's look at this report. So you can. It's a PDF report that gets generated. So let's maximize the screen. And we're going to scroll down. Status and set match with something wrong with it. So let's just figure out what went on. So we go down. Those are the regions you want to quantify. It said it quantified, but why couldn't it do it? So go down.
Not identified.
Oh, maybe because it's lysine. So the lysine was put in as a main component. We didn't have
Oh,
lysine here.
yeah.
So we'll go down.
So we unchecked for lysine.
We didn't.
Yeah, we just did arginine and we unchecked for the lysine.
But there was one area that you're still quantifying.
Okay.
But let's just scroll down and see what the problem was.
Okay.
So you see arginine, it's fine, it's happy. That's why they quantified. If we go down more, we found the triplet, great. Here it's saying lysine, no region. So the area that you ticked to quantify,
Mm-hmm.
it said no region, no area there. So it basically you couldn't identify it. So that's why there was the X.
Okay.
And then we scroll down. Obviously, there's nothing there. Keep going down. So for DSS, you want to quantify it at 0. So we scroll down. Shows you where the area it quantified. Okay. So we're going to close that window. Yeah. And close this is the QC report. Close that. And then right-click here and an edit method. So the lysine is considered a main compound. If we click on lysine and change the main compound, the type, because the main compound means it has to be there. If it's not there, it's gonna have an X, and we're gonna put that as an impurity.
Okay. This one.
Doesn't
This
yeah,
one.
sure.
Okay.
And click OK. And then go interactive edit again, and right click, and then do a test. So right click on the screen and run quantification with report. And let me know if I'm going too fast or too slow. So you can see when you have your own compound or your own botanical material, you're going to really start pulling in different compounds, start defining areas. You're going to test it. It didn't work. See, you go back and forth and try to make it perfect. And again, the good side about Assure, most of the time when I use Assure, it's actually offline. So I'll have my instrument running certain things, and then I'm maybe making a method or modifying a method. Then I get all the data into my laptop. Then I use Assure, and I just basically do offline analysis.
Like the report that we got right now, the same kind of report will we be getting like once you start like quantifying?
Yeah, it'll always be the same report.
Okay.
The same time as if you did an icon, that folder with the spectrum will also have an Excel file of all the quantification numbers. So it
Okay.
contains a PDF and an Excel file.
Mm-hmm.
So let's see for this one here. So usually you keep seeing 2 reports come out, and the reason why, again, this is for industry. For QC report is if you have a technician just running samples, they really don't need to see the summary of that sample. So they have a QC report just saying that it ran, that it was fine. So for this QC report, we can close it. So close that. What you want to see is the one under it, which is the expert report. So let's scroll down.
How do you recognize which is which? which report is like
On
by
the top it'll say expert report or QC report.
Oh, okay.
And if you so it's saying in match team, saying there's no really much imperative. If you go down, so this is basically always an overview of what you assigned.
Mm-hmm.
So scroll down. Arginine, fine. Obviously it's fine because there was no lysine there.
Okay, yeah.
So and then that's done. So let's close that. Yeah, and then right click. We're gonna save this method. So let's just click either store method, second last. And then let's not overwrite that and put this as test 2. Like save that as any name really.
You mean
Just the arginine part. Not with the dot. So just
oh, there's a dot.
yeah, and then not the space as well. Yes, so the 2, put it together. Yeah, because I think sometimes iron test 2, sure, let's just save that. Yeah.
This or this?
Sure.
Okay.
So let's release it. So go to quantify, release method. You're gonna release that open. And then let's name that test 2. Okay. Wicked. So now that is now saved. That's test 2. A method is in that folder that you released out for icon.
Okay.
So let's switch, have someone else, and the next person is going to run a sample using icon with the method you just made. So whoever wants to take it next.
Quick question, Jerry. So you guys ran a lot of spectrum, right? Is there a way to file share that? Like,
I can send them all to you.
okay.
And yeah, I can send. I just need to find it and all of that.
Yeah.
So I will find it and I'll give it to you. I even think that Sarah might have started an S-base for you guys
Oh yeah, of the samples.
of all the different
Yeah.
compounds. So you might have. I just need to search through. So we are done this part now. So let's go to icon. So we're gonna go through icons. So let's go down. Let's open. So just go to any of those samples.
Okay. Any of those?
Anyone that's empty. So just scroll down. Yeah.
Yeah.
Yeah, any one of those, and double click it. So here, this is basically defining where you want this data to be stored.
Save.
Yeah, so
Okay.
that's fine. Topspin 3.2, that's the folder. The next one, let's make whatever name you want. Really doesn't matter.
Okay, it's this one.
February 2, okay.
Test.
12, and it's number 30, okay. So next one is solvent. So we're going to select
Is
D2O. And then we're going to run the natural product 1H13C, the top one.
oh.
Okay,
Okay.
good. And then for the BD Assure, you're going to click, you're going to click that button right there.
Here.
Yeah. And then the screening profile,
Okay.
scroll down, and then she just made test 2.
And what about this one?
No, that you don't need
Okay,
to. And
right.
the bottom, the carbon, we're not going to do. So click OK. And
So
then-
just click the second one.
Yes, because it's only for that proton. The first one is that parameter set was set for something else. Remember? That was just calibrating the pulses and everything. So we're not going to do an icon method on that.
Yeah. So it's only for this
Yeah.
one, and this one is for what?
This is the carbon exchange. So we're going to click on, go to available.
Available.
So all the way to the second there.
Yeah.
Just click on this
Okay.
and then delete. Just click, just delete.
Delete,
Yeah.
right.
Because we're not going to run a carbon right now.
Okay.
Good.
Now.
And then select both of those rows.
Shift.
Yeah, select both of them. And you're
Yeah.
going to submit.
Submit.
So you're going to put in a sample. Sample should we play with? Sure, why not? Let's play with this one. So you're going to put that sample.
Nothing like that.
Click to. There's. Well, yeah.
Now it's running.
Yeah, well, it's still there. It's gonna go down eventually. So now it's gonna run both of them.
He set up a method. It's about all the solvents and all the main compounds inside or something, right?
Yeah, you can do that if you want to.
No, it's okay. So every time before we run sample, we need to set up a new method. The information for our sample, right?
Yeah, you can. Yeah, for sure.
Sucrose and glucose, because those metabolites that vary in the brought samples at Zaraman, showing them, well, we only looked at the 2010. Yeah. But they would vary as well as, yeah.
Between, okay.
Go on. Yeah, between.
Between lines, do you want to see my spectrum?
Yeah, sure, dude.
So it's
Yeah, when I
in,
saw it on there, it just had those three, so.
Which folder?
in nettles.
Which one?
Nettles.
This one top here?
Yeah, I think so. No.
Chemistry student?
You mean last time? Go to this folder, nettles folder.
Oh, okay,
Okay.
sorry. Yeah, this here. This is this folder.
Is it?
Oh, no, but this is... okay, so let me add another.
Yeah. Up. Yeah. Here. Yeah. Data. NMR. And BQCGS 671. Either one. We start from 6. No, it's 10. Here, I'm sorry. 10 microgram per milliliter. Yeah.
Oh, wow.
So, how to qualify and quantify it?
Yeah, so there's ways to actually.
Yeah, this is difficult. You can see.
Yeah, I know. But
I'm just gonna see how long did this experiment? 5 minutes. Yeah. my manual. Oh, sorry. So yeah, this is your compound now.
Yeah.
Okay. What is this?
It's a flagship from Cranberry, you know. Yeah, so it's a
So
lot.
it's cranberry.
Yeah, it's Cranberry flagship, so it's a lot of compounds inside.
I see.
Okay.
Because you can see. So when I say there's a lot of macromolecules in there,
Yeah.
you can see because if the bigger the compound, the more broad it's going to be.
Okay.
So you can see kind of just.
Okay. So,
Huh.
but you know, most of our sample it looks like that. We do not have some pure, you know.
Well, but you can definitely. So, does this compound also have usolic acid and all that?
I don't think so. It's PEGs.
So it doesn't have any olenic
No,
acid?
no. It may have epicatecin or.
Because I mean, you definitely there's like I mean, anything here you can quantify, no problem.
Okay, but we want to, you know, identify it and then quantify it.
I think they would have
Okay.
So is it means we need the sand and the compounds?
You would need to know what that compound is, because you can't without information
Yeah,
from the NMR
yeah,
that this area here
Yeah.
is PAX or whatever it is.
yeah.
It won't know. So
Yeah.
you need to tell it.
I don't know.
Yeah, that's
Yeah.
why you have the spectra base.
Okay.
You know what I mean?
Yeah. So
Yeah. So this might not have it obviously because this was not made for cranberries, but
okay, but I see epicatecin here before in your database.
okay. So, but right here.
Oh yeah, epicatecin.
Let
You
me
can
just-
try epicatecin.
Okay.
And
So is this
no,
your,
it's 400.
oh, so yeah, it's gonna be the same, around the same.
Yeah, 400. Yeah. There must be a lot of epicatecin unit combined together. It's all my compounds. But the polymerization is different, so that's my compounds.
Okay, let's play around with this.
So
It's not working. Come on. Okay, so let me just find this folder.
okay.
C Booker. No, sorry. C data.
Metal
Mental.
and yeah, data
I'm
and 10 micro. Yeah, it's that one.
See how many you can put in there.
Okay. Out of these, do you want me to try and get her solid
Put
too?
them all if you can.
I can just write
Oh,
down
that's
the
the
entire-
that's the spectral, right?
yeah, that's your
You
spectrum.
combine them together. Oh, just move inside.
Yeah, this is you can put whatever in here. Just drag it inside, and then once you
okay.
drag it inside, now you can
Yeah.
pull in compounds and see. So blue is yours. Black is
The database.
yeah.
Okay. Display. No peak display
Yeah, it's
means
just-
what?
Because it's just picking all the different peaks. I want it off because it's making it confusing for me to see.
Okay.
The only hard part, okay. Singlets are hard. Let's keep focused.
You suggest that one's more than singlets?
Huh?
You suggest that one's more than
Singlets is difficult because anything can be a singlet. You know what I mean? So if you have a singlet here and then you have all these peaks,
Yeah.
what singlet is it, right? So I never will try to match a singlet unless it's really by itself.
Yeah.
But when
Yeah.
it's too many peaks, don't do it.
Okay.
You might get it wrong. So there you can quantify.
Oh, these two. So these two is epicatecin unit, right?
Yeah.
And
There's here the mouse
No.
too big. No.
no.
This could be maybe.
shift because of
Could be.
okay because they combine together.
Shift
Right?
can happen, yeah.
Oh, okay. And this, no, it
No,
cannot.
I wouldn't think so.
Yeah.
No.
How you do that? Can I?
Yeah, for sure. Play.
Okay.
Play around with it.
So can I start from? It's here. Is this one R, right?
Yeah. So let's close that. So let's go to this. Click right click. Close.
Okay.
So now everything's closed. Okay. So you want to compare this compound? So take that and drag it into the window. Drag it in. So now it's open. So now go to your folder of your spectrum.
Here. And
Drag it
then
in.
drag it in.
That's cool.
Then,
So now you can start comparing.
okay. Now
So you
it's
can just start pulling in different compounds in here and start comparing if it's there or not. And this really helps you now because now you can go quantify, edit method, or new method, and start to go, oh, I want this area, I want this area.
Because then Maggie told me, he's like, well, the way they want to do it. I'm like, oh, great.
then how I should do?
Hmm?
How I should do? Like that?
What have you guys done in there?
This is my sample,
That's just
PQCJ
your
saver.
packs?
Yeah, PQCJ7, and we compare the efficacy to see which pigs we can use to
Oh, nice.
quantify. Quantify, yeah. So now what
So all the cranberry samples always just look like this mound, like this?
is pegs, I think so.
Well, not all of them, but anything with packs can end up looking like that. Yeah.
Okay, I see.
Okay.
It's really broad.
Yeah, I mean, that,
Crazy broad. Well, we had pack fractions that Sarah had run before, which may look something like that. I mean, yours is a fraction, right? It's which one is a fraction?
PQCJ7.
7, yeah, that one's got a lot of stuff.
okay, yeah. I mean, it's still doable, but obviously it's better if it's less.
Yeah, that baseline is.
Yeah, and I think, well, the experiment you run isn't ideal for running these experiments. So right now I have it set up so that will run. So
Okay.
for example, here, just delete this. If you're gonna run a new sample, whatever here, put in your DMSO. I have two. One is a screen and one is a proton carbon. So you have a proton carbon. It's gonna run a proton and it's gonna run a carbon. And then if you want a full, then if you want a full one, then all you have to do is go to natural product screen, and it's gonna run proton, carbon, 2Ds, all of that in one shot. So, but if you don't want it, then by all means just delete what you don't want and just run the ones you do want.
That whole series, how long does it take, I think?
6 hours.
I'm assuming with their...
8-9 hours. It's a carbon.
Yeah.
open Yeah.
Carbon's 5 hours.
Right.
Yeah.
So they have to be done at night. So
Yeah.
you can get
Yeah. Yeah.
So we will get a lot of spectrons from this series, right? Each run we can get one spectrum, right?
Each one is one spectrum.
Yeah.
Yeah.
Okay.
Your main important is this first one, which is the 1G.
Yeah, then we will choose the best one for us. Right?
True. Yeah, but
Or
this one here is the quantitative one.
quantitative one.
Yeah, some NMR
Yeah.
experiments are more for qualitative, it's just identify things,
Okay.
but not quantitative. You can't quantify with using it. And some of them are.
Quantitation.
Yeah.
And which one is for identification?
It would be CPMG and JRES.
CPMG
And JRES.
These two can be used to qualify.
Yeah, can help you quantify.
Qualify.
Identify.
Identify,
So it's
okay.
qualitative.
Okay.
information.
And then the others is
Others is, again, qualitative. The 2D.
2D, and these three are 1D. First 1D, right?
Yeah, all you're running is 1D. I mean, if you start to run your cranberry and you have 2D,
Okay.
then you can do the exact same thing. Drag in your 2D in here,
Okay.
and then drag in, let's see, DMSO. Then you can drag in your 2D in as well and see if it match. You know what I mean?
Okay.
So now you only have 1D, so you can only use the 1D.
Okay,
Right.
that makes sense. Okay, so can we compare my sample and the efficacy that one to see?
The two, you can only do the 1D right now because you only
Yeah,
ran
yeah,
1D.
yeah. Can we do 1D right now?
Yeah, for sure.
And to see, maybe we need some other database, right, for the quantification.
Yeah, or if you guys have any standards, so whenever you run a standard, make
Oh,
an S space,
standard, yeah,
make an S
just-
space of it, and then from there you can start searching for it.
Okay, makes sense.
So, yeah.
Now,
He probably doesn't know.
huh? What? Oh, no.
Dave would have heard.
And here.
So what other compounds are in here?
OPEX, you know, the epicatecin is just one unit of compounds, and my compounds is compared a lot of epicatecin together by some linkage.
And sugars and stuff like that?
Yeah. So it's complex. Yeah, so we still can find some peaks used to quantification, right?
Region we're looking at, the aromatic region.
Yeah.
Is it pumpy like that in the sugar region too? Down below 5 ppm?
I'm not sure.
You mean my concentration?
No, like the sample. Can you? What does it look like at low ppms?
Like
Because
underneath
that's
5.
just aromatic region.
Yeah, so just
Go towards the end.
yeah, so go towards the end.
Oh.
Yeah, just stretch it out. Yeah.
Okay.
Yeah. So even in the sugar region, it's got that broad.
And in the sample, is it clear or is it viscous?
Does it
Is
dissolve completely?
Yeah.
Yeah.
Yeah, it's 10 milligram per milliliter concentration.
And it goes all into DMSO. There's no solid at all.
No, completely done.
Did you filter it?
No.
No.
Yeah, but it's completely dissolved.
Clear.
Yeah, clear.
Yeah.
You see, leak peak can be used, right? Or
I
not?
think it's because it's such a mixture of compounds.
Yeah, this is a bit more broad than usual. But again, we can use other techniques. We can use other techniques to we can try to use other techniques to see if we can get better line shape and more resolution than this. So the CPMG would definitely give you sharp lines throughout. It will remove all this broadness. But it's only for qualitative but not quantitative. But it gives you the ability to identify what's in there.
Okay.
What is CPMG?
Those are the 4 NMR gurus that wrote that pulse program, wrote it separately, and then they were going to publish at the same time, and they were like, oh, let's just join it together, and then they made it CPMG.
Okay.
So that is just a method for you to, it's a filtering technique that focuses on small metabolites. Let me see. I have data. So I'll show you some data where I ran on blueberry or ginseng, which is obviously not exactly the same, but I'll show you like what they can be done.
Yeah, so blueberries have packs, so I mean,
Yeah.
if they're present in the extract, I mean, it's highly concentrated. I would imagine the extract baseline has some noise to it like that.
Is it common for you to filter samples before you put them on NMR?
Well, the extracts have to be filtered, right, or at least...
Yeah, I usually spin it very extreme high speeds, and that usually helps out. Filtering is fine, but when I did with biological stuff,
Leaves won't completely dissolve either.
sometimes I find that, well, it depends on your filtering. Sometimes I find that it leaks a bit, the filter, and I see some of it in the air, in the aliphatic region. So it depends on your filter as well. And once I saw that one time with one of my samples, I just stopped. I just spun it at high speeds, and that was fine with me. So, for example, I have a mouse actually. So this is ginseng you see on screen. Which is more resolved than that for sure.
Yeah.
But what we can do to it is if you put CPMG into it, it's exactly the same sample, but you can see all the broadness is all gone.
Wow.
So it removes any macromolecules, any polysaccharides, anything that will make the spectrum broad. So it filters it out, and it only focuses on the small metabolites. This is good for qualitative work, so you can now use your S-space to identify, but this is not quantitative because it does a lot of different cycles, and because of that, you do lose a bit of accuracy in terms of whatever your quantitation might be.
So what's like the molecular weight cutoff that it would filter out?
I wouldn't know the exact number, but anything, again, like how big are the packs?
Well, they range, right? So the dimers are still probably considered small. Like A2 would be like molecular weight of 576. Trimer would be like, you add 290 to that.
Yeah, dimers I think would be fine. As
700
trimers, I
trimer.
think as you go bigger from there.
Yeah,
Then-
so as they get over like 1,000, like
That-
in this
yeah,
sample,
yeah,
she'll
for
have
sure.
some larger oligomers, tetramers, pentamers.
Yeah.
Mhm.
So those would be cut out.
Those would be cut out, and then you just basically get more sharp lines and.
Well, if you were trying to, yeah. Well, if you were trying to pick out like epicatechin or even procyanidin 2 out of that mixture, that might help because then it would get rid of the larger packs and you would just see the.
Yeah, like this is like I would consider more of a worst case scenario, but what's nice about it is let's focus on something like this here. Like if you want to know if this is here or not, if you run the CPMG, then you will remove all this broadness, and then you can go, you know what, this is actually this peak now. But right now it's everything broad, so you're not sure.
Is that in DMS though?
Yeah.
Yeah.
DMSO.
You can try it out, why not? It's in your parameter set now, so we can just run it and see what happens.
Okay. Now, if we find the peak, how we quantify?
Okay, so well, this sample is running long. How long do we run this for? 16 minutes. Oh wow, okay, we should change the number of scans.
Yeah, we can just use any peak and how to quantify.
Okay,
So I'm just gonna put everything on.
so you guys will need to consider what sort of standard material you're going to use to
Yeah.
do referencing.
Yeah, for my-
to do quantification.
You know, for my this sample, I will use epicatechin or procyanidin A2 or B2. So epicatechin it can be used because it's just 1 unit of my sample.
For the quantification,
Yeah.
since it's an external one,
Okay.
you can use anything you want, any compound you want that you
Okay.
know
Yeah, it will be there.
it will be there. So you're just going to make a pure sample of something.
Okay.
So some people use caffeine or whatever
Okay.
it is, and then you make a method where it's going to quantify that,
Okay.
and then there's going to be an option where you can store that quantification information. So then now when you use any other method for your whatever samples that you have, they'll take that information
Yeah.
and quantify any compound in there.
Okay.
So you guys just need to figure out what quantification standard you guys are going to make.
Okay, so here, if I use epicatechin, I can just quantify the concentration of epicatechin in my sample, not you know?
You could, so if you use any other sample like propanol or like let's say
Yeah.
caffeine,
Yeah.
and you quantify that, you
Yeah.
can save that information,
Okay.
and then now any other sample that you have, you can quantify anything that's in here, any compound. So, so that's one thing that you guys would need to kind of consider. So,
So this is derived from cranberry juice, so you see what some of the problems are going to be
Yeah.
in analyzing juice. Because previous samples that Sarah had run were either leaf extracts or fruit extracts. I think she ran fruit packs. But from juice, it appears to be even more complex because
Yeah.
you've got sugars in
Yeah.
there, and we don't know if the sugars are actually attached to the polyphenols or separate molecules in addition to the polyphenols. But the multi-toss spectrum is pretty complex.
so the
Yes.
juice is just straight up in this liquid form. You guys dry, like how did you?
So juice concentrate, right? So she chromatographed the juice concentrate.
Okay.
Got rid of free sugar, but bound sugars are, you know.
Yeah, it's still
Still
there.
present.
Yeah, still there.
Uh huh. Oh, I see.
So,
Huh.
yeah.
See.
You'd also have to, You'd have to adjust the baseline of that, right? Because that TMS all the way to the far.
It's too bad we don't have
At
like
like, at 1
Andrew's fruit
ppm.
extracts because
Oh, I made the mixture
we'll have some of the same problems with those.
of ursolic and polinolic.
And how much samples in here? Around. How much sample?
2 mg per milliliter. I just added 500 microliters of.
Oh, okay. Yeah, that's right.
The
Judy, you
concentration
guys
is 2
have-
mg per ml, but
Just a quick question. You guys have juice analyzer, right?
Yeah.
Now, what juices does it analyze for?
Apple. Actually, any juice, like apple, orange, grape.
So, does it analyze for cranberry?
Well, we have a quantification method that will take all of the, sugar, citrate, and all that, but nothing that's specific to that fruit, though.
So, does it identify how much of each juice is present? Like, if you had some unknown sample of juice, it would say, okay, it's 10% cranberry, 20% orange, or something like that? Or,
Yeah, so it would tell you, one, the concentrations of all the small molecule metabolites, and also will tell you what region of that juice is from.
okay.
And also will tell
Oh,
you,
okay.
it will tell you the mix as well. Yeah. The only thing about that is the juice screener is something that is in Germany, so you will acquire it, and then you send it, and then they give you the report.
yeah,
I see.
now it's the same problem as to.
Yeah.
I mean, I wonder if they run into some problems with cranberry juice samples for that reason.
Yeah.
There's so much variation.
I mean, even apple and orange juice, it can be quite complex, but the thing is, in Germany, they ran like
Yeah.
thousands of samples, so I guess they could really understand that variance
What
more.
They have the database.
They have a huge database.
Yes.
It's extreme.
Do we have database
For cranberry juice? Not
No.
yet.
for cranberry?
I think this was one of the things that Kim mentioned to me a long time ago is that they wanted cranberry juice samples over in Germany for that purpose.
Mhm.
I haven't heard anything more about it. But I could see why, because, that's one particular type of juice that she has there,
Yeah.
right? A juice concentrate, and that's what the profile
Yeah.
looks like. But, they could vary.
For sure.
Because processing effects, right?
Oh yeah, for
Yeah,
sure.
I
You're
think
right.
that's why it looks so different from regular cranberry extract.
Mm.
Anyway.
So we have no database, so till now we cannot deal with the data we got.
We can quantify individual compounds, and you can look for differences between one sample to the next. But we won't be able to identify everything because
From and
okay,
Yeah, tonight I will.
not yet.
I'll search through and I see if I can find it. I can log into my spectrometer in Boston and then see if I can find any of your data. And if I can find your data and hopefully there's a spectra based, then that definitely could give you guys a head start. If some of them already made, I think Sarah already started it.
Yeah,
Yeah.
that will be great.
And that would be good. Okay, so that's done. Let's click OK. So you see that screening is done.
Yeah,
So let's go right click on that.
here.
Yeah. And then go expert report.
And they know they have their side, which of course on.
I gotta remove it.
Remove it.
Yeah, I got it. It's easy. I got it. So, one thing you guys also have to decide on is if you guys are going to do NMR quantification, you guys have to decide what sort of quantification standard you want to use. So it could be any
This one
compound.
is the off.
Yeah.
You want to run
No.
that one? Sure, let's run that
Okay.
one. So it can be any sample that you want, and then we can make a method so it will quantify that pure sample, and then from then on, it will make a file, a quantification file, so that any samples that's run using the same pulse program, it'll correlate that quantification information, and you can now start quantifying any other material after. Any material, doesn't matter. But the reference standard is something that you want to choose something that doesn't degrade too fast, so you will not put like a sugar as a reference standard. So
What do people normally choose?
caffeine is very popular because it's very easy to analyze, but it also degrades.
We want something that's not normally in cranberry, just as a reference. You're
It
talking about an internal standard?
there's
now?
external.
External.
The external could be anything. It doesn't matter.
Oh, okay.
Almost done. Now it's Right
So right click and go expert report. So we just,
Export.
oh sorry, expert report.
Oh, okay, I'm sorry.
So for me, I mean, when I do quick quantification, I have a
To report. Well, oh yeah.
Yep. So here I have, like, for example, an arginine sample that's pure arginine, and this was done in Switzerland and it's sealed.
Yeah.
So if you guys make a reference standard, you guys can seal the tip of it, and then see how long it lasts. So you guys need to make one. You guys decide whatever that might be.
Okay.
You can definitely purchase as well,
Yeah.
but they're expensive.
Yeah.
Obviously, you guys can just make it on your own.
Latest fire seal would just
Is
like
this
throw a
special
Bunsen
cap?
burner.
We burned the top to melt the glass.
Okay.
Yeah.
So that's in DMSO.
This is in D2O, so it really doesn't
Oh,
matter what
D2O.
solvent you use too. So D2O, DMSO, the correlation of the information is found. It's still the same. So scroll down. So 0%. Okay, let's go down. Why didn't it identify it? That's interesting. Down. Okay. So identified arginine, which we obviously know it would, because we'll go down. Awesome. The triplet was not identified, so let's go down.
We make
Oh,
our own
okay.
data
I guess
way
that's the
accurately, right?
Yeah.
Yeah.
So that's the thing.
That's a concern.
You would need to.
So when you say expensive, how expensive are the purchased ones?
I actually don't know the exact price, but
Do you think we'd be better off purchasing them? I mean, if it's
search through. Sigma, Cambridge Isotope, NIST has some. And Brooker, I don't know. I mean,
CIL is pretty reasonably priced when list.
yeah.
But it could be any compound.
Any compound, obviously for NMR, it has to be an NMR reference.
Right.
Yeah.
Yeah. I think probably I'd want to purchase one just to be certain that it really is the concentration that it
Mhm.
claims to be. Because I think our balances are
Yeah.
okay for our purposes, but
Not for our standard.
I'd rather be more accurate for this, you know.
And you guys, I mean, since you guys have other analytical tools, if you guys do make your own, then you can verify it with another HPLC or something like that, and then use that concentration information as whatever it is.
Well, we could.
How long it can last?
For these, last around 4 to 5 years because it's sealed.
Do you blanket it with nitrogen and stuff like that, or?
That is the procedure, but it's all done in Switzerland, and then they give you, like, from Broker, they give you this sheet about like all the different, like, 6 significant digit, like this is how pure it is, and I'm like, okay, sure. So
There's
that's
something to put in your budget, a reference standard.
I know, I'm looking it up right now. See if I can find one. That's-
So, let's see. Next thing, what we can do first is to run. I'll run your sample, right? So,
This guy again.
oh well.
Yeah, the guy we're interviewing. To meet him at 3:20, and then he's giving a talk at 4. So.
That guy must be tired.
Oh yeah, he's gonna have a long day today and tomorrow.
So yeah, someone could run it. I mean,
It's okay. It's okay. It's okay.
You can take that out. Sit properly. I don't want to sit in front and fall down.
so after you run it, then someone else, we're gonna start. We're gonna make a reference file, and then right now you guys don't have anything for reference. I'll go through the procedure. We can use the arginine for now to make it faster, and then maybe once you guys know what you guys select, then we can make a method for that as well. So you can run your sample. So just
Oh, can't put that. It doesn't take like the space.
yeah, because this is going to be the folder.
try the
Like-
database instead of the samples.
What do you mean?
He said that the general company they have database for the juice.
Feb
then
and
we
today's
use the database instead of the standards.
12th.
But we still need a general quantification standard
So-
for like all quantifications to be referenced.
10?
Yeah, sure.
Yeah, you mean with the juice analyzer? I
Yeah.
think from what he was saying is they don't release that, you have to send samples.
Yeah, you send.
do the
Yeah, you actually send the data. If you want to, you can send samples, and that's more of an analytical service.
Okay, so they do not sell us the data.
No.
You just send it. Okay, that's that. We need the database.
What do I
We have
add?
to make a lot.
So let's just do a natural product screen. No, sorry, the proton carbon, and we're going to take away the carbon.
Oh,
So click on available near there. It basically highlights that that row. For the ZGIG, yeah, and then click delete. Yeah,
those two are.
good.
Yeah.
You just want a quick scan, or you want like detailed analysis? Because right, if you click on this one here, right now it's set on
64, which is
64.
like 5
That's
minutes.
this one's 16 minutes.
Oh,
So click on that. So let's put that for now. 8 minutes. 32. So make it 8 minutes.
Which one is that?
the
This one?
64,
64?
to 32.
Yeah, we'll change it to 32.
Okay.
Okay.
Number of scans. Okay.
Awesome. And then highlight both of them and then submit it.
How do I do this?
Now click
Click
highlight.
this one
This
too.
one
Yeah,
too?
awesome. Now click the bottom there, submit, and that's it. Okay, yeah, it's gonna eject.
Just hit OK and
Just
then
hit OK
OK.
and OK.
Yeah.
Yeah. And OK. You should.
Yeah. Now it's.
Hopefully later you guys will get an auto sampler.
I hope we do
That
at
would
some
really would help.
Yeah.
Really would help.
If so, like, since the students have access to changing scans and pulse and stuff like that, if one person changes the pulse, does that?
It's only for that experiment.
Oh, all right.
Yeah, no, they're not.
Not screwing it up for everybody.
Yeah, yeah. They would have to go to Topspin and actually like save and overwrite. If they go that far, then I'm like, okay.
Oh, we could even use something as simple as ethylbenzene for a reference standard.
Exactly. Anything that you can.
They're not extremely expensive,
DSS
Kelsey.
is the
You can
internal
put it in
reference
your
standard.
budget and take
What?
out something
DSS.
else.
No, because I,
It's
without,
an
it?
internal.
it's
reference
just
without
standard.
this one, we have 34 left, or 36 bucks
That's
left
an
over,
internal
but I need,
standard.
if we don't have to
Hmm?
order
That's an
something
internal
else, then.
standard.
It's one of your internal standards, right?
Yeah.
DSS.
Yeah.
I mean, I could always just leave that in there.
Labs. Some of it comes in a tube. Yeah, comes in a tube. They range. Some of them are like $100, some are more, but
Yeah, I found some that were
Should we pick one that doesn't overlap with a lot of our spectra? Like, we have a lot of stuff that overlaps in the...
yeah, or is concentration important? Like,
Again, the external the external standard again doesn't.
it doesn't matter.
It doesn't matter because
Really doesn't.
all it's doing, it's gonna say that this proton is this intensity, use this pulse program.
Okay.
It's a separate spectrum. That, So it just correlates that information, so it knows exactly the power and everything. So
Ah.
once you start running any other compound after, it'll just correlate that.
Does it have to be in DMSO or
Oh no, it can be D2O.
it can be in D2O?
Relative use.
Yep.
So we have it tomorrow.
What?
Just get them out of the way.
I don't know.
Yeah.
Are you doing training tomorrow too?
I am gonna come for a while, but I gotta go back after. So I'll come in the morning and see how it goes. And definitely, if I'm going back to Boston, I don't want to leave too late. But it seems like, yeah, I'll come again tomorrow, because tonight I think I'm gonna. There's some optimization I want to do more, because it's not fully perfect. Yeah.
How late will you be here tonight, you think?
I don't know. Last night was pretty late here. Like, it's fine. I want it to be perfect for you guys before I leave. So next will be telling you how to do the quantification standard run. So I'm going to teach you guys that, which is very simple. It's basically you have the same method, you create the same way, and all you're going to create is say, this is a calibration standard. That's all you can do, different from anything else. And then when you run the method, so example, you have your arginine method that you made. All you're doing here now to make it that run as a quantification standard, you go to configuration.
Are we gonna have to enter the password in order to do that stuff?
Yes. Yeah. I think it's important to have it, I guess. So here it goes quantification sample setup. You're going to say, I want to perform the quantification, insert sample position. Doesn't matter because you guys don't have an auto sampler, but sample, you can name it whatever it is. So we can go arginine. Let's go arginine. Solvent is D2O. Experiment. This.
ED? No.
So the
Fish.
it's going to be the sure. Analysis method is going to be your test 2, or we have to modify that one, but this is just how it's going to be done. And what happens is when you save and you run, before you do your run, it's going to say here, there's going to be an extra option saying, please run quantification standard. And it's going to please input that sample, then it's going to run your method. And basically, if you, in the method, we still had to define arginine is what concentration. When you made the method, all you said percent mole. You didn't even specify anything. But if you can make a quantification reference, you can do the exact same thing, but you're going to tell the method that when you quantify arginine, make this 10 millimolars. So then what happens is once it runs a the quantification standard, it identifies arginine and says that this area here is 10 millimolars, and it's going to save that information.
Okay.
So that's the only difference that you're going to do. And we're going to do that before you guys leave. Since that sample is running. I just did something. Just going to close this for a sec. So we're going to edit test 2. This is the method that you made. To make this the quantification standard, everything else is basically the same. You now obviously, I don't really need lysine. I don't care that there's water. Find DSS could be in there. You're going to change this and you're going to say millimole calibration. In the calibrate tab, you're going to say this is the assure quantification calibration. So it's a proton, arginine, and you're going to tell it what this concentration is going to be. Sorry, let's see. Something else set here. Quantification. So that's saved.
Why did it say reference peak not found?
That's for this guy
Oh,
here.
that, okay.
So the parameter set that you use, it does a reference check. So if you had DSS, it'll find DSS and just calibrate to 0. So it said it didn't find it. That's separate from this. You still have to release it though. So you have to release the quantification standard. Arginine. I'm spelling wrong.
That's correct. Arginine. NINE.
So that's released. Quantification. And then you save it. Update the parameters.
Can I just ask you a quick question
Yeah.
before I go back up? I was just looking at this list of standards from Cambridge Isotope Labs. There aren't too many choices in DMSO or D2O, but I found this 2 millimole of sucrose. Only thing is it's in 90% water, 10% D2O.
Yeah,
Is
that is. I have
what's
it.
that for?
That is for water suppression
Oh,
test.
okay.
So you're really testing your gradients. You're testing more of the hardware of your instrument.
So it's not for quantification.
No.
So, alright. So I'm not sure if any of these are appropriate for quantification. Does anything jump out at you?
Yeah, most of this is for the maintenance of your instrument. Yeah, it doesn't seem like the isotope sells any Cambridge isotopes. I mean, maybe call them and see if they could make any. Again, I mean, most of the labs that I talk to, they make their
How
own.
much
There's-
time
there's
does
no-
it take?
Let's just
Do
keep
you guys
going.
have like a
For
4 or
the
5 digit balance?
Ursolic acid, the method.
Yeah,
Oh,
we can
he said
find
it
one.
was
10 minutes?
Yeah.
15?
something like that, yeah.
So that's
Okay.
definitely one way.
So we need to wait about 2 minutes to prepare. I mean,
No, for the standard, we need to weigh out as much as we can weigh accurately.
yeah,
2 milligrams, I don't think we can weigh out.
yeah, but we buy is 5 milligram bottle.
Oh, you're talking about the standard compounds
Yeah.
for qualitative purposes. I don't even know if those guys weigh them out accurately enough. Like if we buy a reagent from a company and they tell us
Yeah.
5 milligrams,
Yeah.
it's plus or minus 0.23.
Yeah,
or
0.3. Yeah.
So, for
Yeah.
reference standard, that still seems too much to me. That's
Okay.
why I wanted to purchase one. But I'll see what Sigma has.
Yeah, I can check what we have at Brooker
Mm.
and what we have. We usually have some, but they're so expensive.
Yeah, I mean, if you could just recommend a couple of.
Yeah, I'll try to think of some.
All right. Thanks a lot.
Then I'll just put all these.
So I have to.
on the list and
Yeah.
that
The
way-
only thing, every time you make a change in the configuration, you need to restart the icon. So this is running. I'll wait until it finishes
Okay.
running.
I'm just gonna
Restart
try to
it.
get as
Time
close
this
to
is
500 as possible.
Sounds good to
Okay.
me.
Go here.
Oh wait, Dr. Nato.
4 minutes.
You're
You
going?
have to think this.
Yeah. So I don't know when I hand it in, they're not like, oh, wait, I didn't look. You're so good. All right, thank you. Grants.
Oh, actually, I think I did something. Just thought of something. The quantification of this thing. You're not doing calibration. Sorry. So this one, percent mole of reference. It doesn't really matter whatever percent mole of reference. And then in the calibrate tab, you say that it's 10 millimolar arginine. So what this means is that you're saying arginine is 100%, and that when you identify it as 100%, make that as 10 millimolars.
This is the concentration.
Yes, yes.
How
So,
you know it's 10?
This is strong.
well, not just that. I also, for my standard that I have that's sealed,
Okay, so you know
it's 10
10.
millimolars. Yeah, yeah,
Oh, that's your standard.
yeah. Whatever your own, whatever you want to put as a concentration, and you put that as moles
Okay,
reference.
so
The calibrate is only when you actually going to calibrate from something. So, mole reference, calibrate. So you don't click on that. Save.
How often do you recommend doing a reference calibration? Like every time you do a run, or?
That's the hard part because we usually ask to do all the line shape and sensitivity tests like every day or every week at least once, so it maintains the instrument, and then you really don't need to run that. But from the fact that you guys don't do any of this sort of optimization of the instrument just to make sure that it's okay, yeah, I might say run it. And it depends because everyone uses it all the time, but you know, I would say maybe once every time you run your experiment.
Right.
every time you want to quantify, you need to run the reference quantification method,
Mhm.
right?
Yeah.
Okay. Then they will give us a report about how many concentration in your sample.
Yeah, if you make your method to say, so let's just say now you ran the quantification standard.
Yeah.
When you edit your method, I'm going to open another method here, sorry. Edit another method.
So if you want to quantify, you will use the quantify methods, not the methods enumerated, right?
Mm-hmm. So
Enumerated is for the analysis.
that's for analysis. So if you want to do the quantification, so the quantification, let's just say we ran the one I just made, the quantification standard.
Okay.
If you're doing the analysis method,
Yeah.
what you would choose is here you would choose the calibration to what you want. So let's say you want millimoles.
Analysis is
Yeah, so you would change the concentration to millimoles here.
Okay.
Calibrate. You can either do it two ways. Here you can import that calibration reference.
Okay.
So that arginine that you ran, which was 10 millimolars, it ran and it quantified. You'll
Okay.
pull in that spectrum into here,
Uh-huh.
which, so here obviously does not contain anything, but it will then say that it has it, and then you save the method. So now the method will have the quantification information. So now when it runs any of the other spectrum after,
Okay.
it's gonna give you the
Quantify results.
the concentration in moles per liter.
Okay.
But you have to run the quantification standard first.
Okay. We need to have a database. Right?
But, well, there's two ways. I mean, if you, one, obviously it's nice to identify it, but for example, if you really don't know what your if you know that it's maybe 1 or 2 protons in certain areas, then you really don't always have to match it to an S space,
Okay.
right? You can just define this as one area, this one area, but you still need to know how many protons are there. That's the only thing you need to know. And that's, I guess, the harder part more than anything. So that's the sample you just put in.
I can just print that just to see, compare with the previous one.
You want to compare it, or you want me to print it?
It'll be saved then. I can print it anytime, or
Yeah,
we don't
it's
have to?
it's saved in the data
Okay.
in the hard drive.
Okay, then no problem.
I mean, what is this? This is a mixture again.
Yeah.
Let's find that file. This file here. Yeah, so it is very similar sample. Let's shift it a bit. Let's look it together. The blue one is the one you just made.
Okay.
See, it's missing this beautiful area here.
Yeah.
This is made in DMSO,
Yeah.
so this could be water. So you can
The
see.
red one is the one which I made now.
No, blue is what you made.
Blue. Oh, okay.
Blue is what you made.
So now there is like water in it.
The red one had water in it.
Oh,
It's
okay.
like,
So probably the one I
Yeah.
did like before wasn't like dry. The one which I did now is a dried sample.
yeah, I mean, there's water always will peer through. You see the
Mhm.
water coming here, but the one you made before just like dominated the spectrum. Totally just. So the one you.
So if we have to like quantify like one particular peak, how do we do that? Like we just have to select the area like how you said before and
So let's. Let's see what I should do in the shore first. Okay, so there's two ways of doing the quantification. Obviously, one was in the ensure.
Yeah.
If you guys want to do it in top spin, let's see. We need to. Okay, let's run the Argentine spectrum first. Okay, I might just close this because